So today we are beginning with the chapter on circle, class 8, ML Aggarwal. So before beginning the chapter, let us know certain things which is important for the chapter. For example, if this is a circle, this is the diameter of the circle, and with the center to this point is the radius. So we can say radius is half of the diameter. If there is a line that touches the circle in this way, this is known as the tangent. And if there is a line to be drawn on the circle, this is called a chord. So now let us begin with the exercise directly. So let us see the first sum, which tells us a circle is to be drawn with the center O and radius 2.5. Draw two radii OA and OB such that angle AOB is 60 degree. Measure the length of the chord AB. So now let us see how the sum needs to be proceeded. I have already made a line with 2.5 centimeter as the measurement and placing our compass with the exact measurement, we draw a circle this way. Now on this we have to make a 60 degree angle that measures angle AOB as 60 degree. So I have drawn the angle 60 degree and we got AOB as 60 degree here. Now we have to draw a chord from B to A and state its measurement. So I have already drawn the chord AB, and now let us check what is the measurement. So it is basically 2.5. So BA is 2.5 centimeter. Now sum number 2. Draw a circle of radius 3.2. Draw a chord AB of the circle such that AB is 5 centimeter. Shade the minor segment of the circle. Now let us check how to do the sum. As you can see, I have already taken the measurement of the radius 3.2 centimeter and placing the compass and drawing the circle. Now we have to draw a chord of AB as 5 centimeter. So now to draw AB as 5 centimeter chord, we place the ruler and measure where it is 5 centimeter and just draw the line. So on drawing the line, we get the chord AB as 5 centimeter. Now we have to shade the minor segment. To shade the minor segment, so this is basically the minor segment and this is the major segment, other major arc that we get. So we shade it. And this is the minor segment. Sum number 3. Find the length of the tangent drawn to a circle of radius 3 centimeter from the point at a distance 5 centimeter from the center. Now let us see how to do the sum. Now see, we have drawn a circle and PT is the tangent. Okay. Now from the center, if we draw the radius where it's dropping, we form a 90 degree. Now the triangle CPT is formed. Okay, CT is given as 3 centimeter and PC is given as 5 centimeter. On applying the Pythagoras theorem, we will get the PT that is required. So now you can see CT is 3 centimeter, CP is 5 centimeter, that is given. And angle CTP forms 90 degree. So from triangle CPT, we get CP square is equal to TC square plus PT square. Applying the Pythagoras theorem and putting the PT here, PT square here, 5 square minus 3 square, we get 16 and PT as 4 centimeter. Sum number 4. In the adjoining figure, PT is the tangent. So you can see PT is the tangent to the circle with the center C. Given CP is 20 centimeter. CP is 20, it is given, and PT is 16, it is given. Find the radius of the circle. So CT is the radius and here we get the 90 degree. So on applying the Pythagoras theorem, we will get the radius or CT. So this is as similar to the third sum that we have done. Now let us see how to do it. See, we have just drawn the figure and just placed the values. So triangle CTP, CP square is equal to TC square plus PT square. Applying the Pythagoras theorem, so by this we get TC square, that is root over TC as root over 144, that is 12 centimeter. So we get the radius CT as 12 centimeter. So for sum number 5, 1. In each of the following figure, O is the center of the circle. Find the size of each lettered angle. Now, before starting with the 5 sums, I want to let you know some things. That is, if this is a circle, so half of the circle is known as the semicircle. Now, this semicircle here, it forms a 90 degree. So similarly below it also will form a 90 degree. So this is the general rule. Now let us proceed with the sums. So as you can see, I have drawn the diagram of 5, 1, and I have given angle A names. Angle ADB as 90 degree and angle ACB is also 90 degree. So to find the angle X, we know that sum of the triangle is 180 degree. So X is equal to 180 degree minus 90 plus 32 degree, that is given, and we get it as 58 degree. Similarly, to find Y in triangle ABC, we get Y is equal to 180 degree minus 90 degree plus 50 degree, that is 40 degree. For 5-2, this is the diagram, and it is said that AD is parallel to CB, and this is the 90 degree because angle in a semicircle is a 90 degree, that we know. So as AD is parallel to BC, X is equal to 37 degree because of alternate angles. So we get X as 37 degree. Now to find Y in triangle ABC, we know X as 37 degree, we know 90 degrees, so we subtract 180 degree minus 90 plus 37, we get as Y 53 degree. Now 5-3, this is the diagram that is given, and AC is equal to BC, that is given. As AC is equal to BC, so we can see an isosceles triangle angle A is equal to angle B, that is x is equal to y. Now x plus y is equal to 90 degree. So as y becomes x, so 2x is 90 degree and x is equal to 45 degree.